Hi, welcome back to Eccentric Cosmos. Today, we're going to talk about quantum mechanics, a fascinating and mind-bending topic in physics. Quantum mechanics describes how the world works at the tiniest scale, like atoms and subatomic particles. While it might seem complicated, we'll do our best to break it down into simpler terms so that everyone can understand. So, let's start with the basics. In classical physics, we think of matter as having a definite position and velocity at any given time. However, in the quantum world, particles behave differently. Instead of having a definite position, particles exist in a wave-like state that we call a wave function. The wave function describes the probability of finding a particle in a particular location or state. Think of it like a map that tells us where a particle might be. Now, let's talk about something called superposition. In quantum mechanics, a particle can exist in multiple states at the same time. For example, imagine a coin flipped in the air. In classical physics, it either lands on heads or tails, but in quantum mechanics, it's like the coin is both heads and tails at the same time until it's observed. This superposition can be difficult to grasp, but it's a fundamental concept in quantum mechanics. Another mind-bending concept central to quantum mechanics is entanglement. When two particles become entangled, their states become linked in such a way that they are dependent on each other. Even when separated by vast distances, changes in the state of one particle will instantly affect the state of the other. Einstein famously referred to this phenomenon as spooky action at a distance, but this phenomenon has been experimentally verified and has led to many potential applications, including quantum computing. One of the most fascinating applications of quantum mechanics is quantum cryptography. Quantum cryptography uses the properties of quantum mechanics to create secure communication channels. By encoding information onto entangled particles, it's possible to create a communication channel that is impervious to eavesdropping, as any attempt to observe the state of the particles will immediately disrupt the communication. Lastly, let's talk about the famous double-slit experiment. This experiment involves firing particles, like electrons, through two slits and observing the interference pattern that forms on a detector screen. Surprisingly, the particles behave like waves and produce an interference pattern, even when fired one at a time. This experiment shows that particles can exist in multiple states at the same time and that their behavior is probabilistic. So, there you have it, a simplified version of quantum mechanics. While it might seem strange and confusing, quantum mechanics has led to many amazing discoveries and applications in fields like computing, cryptography, and medical imaging. Even though we still have unanswered questions, like the famous Schrödinger's cat paradox, scientists continue to explore the world of quantum mechanics and push the boundaries of our understanding. Thanks for watching, and be sure to subscribe to our channel for more science content.